Bismillahirrahmanirrahim. So in this video we will discuss and we will implement machine learning. So this is part 2. In previous part we have already discussed about artificial intelligence. So this is the first branch of AI, which is known as machine learning. So we will discuss what is machine learning, then we will see the difference between rule-based versus data-driven programming, then we will discuss machine learning real world application, and then we will explore different types of machine learning such as supervised learning, unsupervised learning, and reinforcement learning. Because before understanding machine learning, you need to understand different types of machine learning, because without understanding ML types, you will not be able to implement a machine learning project. Now before that, you also need to understand different types of data set features that we have heard a lot of times for data set, how we do trend split, how we select a model, how we evaluate a model, and how we finally deploy the model so that people can use and take advantage of our trained model. Once we understand that, then we will discuss different types of models such as classification models, regression models, unsupervised learning algorithms. And so once we understand all these types of model, then we will understand different matrices that are used for evaluating our model. Because once you train a model, then you have to test that model so that you can check your model performance, that how good your model is. For each types of model we use different matrices, such as for classification model we use different matrices, for regression type of models we use different matrices, for unsupervised learning models evaluation we use different matrices. So we need to understand all these matrices. So we will also cover evaluation part in this video as well. And finally, at the end of this video, we will implement an end-to-end machine learning workflow in Python using scikit-learn library, where the purpose will be to get a diabetes disease dataset, and we will train a model that can easily detect diabetes patient disease. So let's get started. What is machine learning? Machine learning is a branch of artificial intelligence that enables computers to learn patterns from data instead of being explicitly programmed. So in machine learning, the key idea is very simple. Instead of writing if-else logic that we do in normal or rule-based programming, here we provide data set and the algorithm learns pattern or the mapping between input plus output features. So here we train computers or models to learn examples such as data and make predictions or decisions, just like human learn from experiences. For example, we have this textual data and our problem statement is to detect emotion within each text, that either it is a positive or negative. So the first step is data collection. In second step, we will train a machine learning model on this data so that the model learn patterns between the mapping of features and target, and the model adjusts itself to reduce errors. Once we train model, then we will test that model with matrices so that we can check how good our model is. Now before understanding and jumping deeply into machine learning fundamentals, we need to differentiate between traditional programming and ML programming, also known as rule-based versus data-driven programming. So in traditional programming, programmer explicitly defines rules and logic. But in ML programming, model or the trained model learns patterns automatically from data without need of predefined rules. In traditional programming, input is based on rules and data, while in machine learning programming, input is based on data plus output, expected output, which is the training process. In traditional programming, output is fixed result based on given rules, while in machine learning, train model that can make predictions or make decisions. Traditional programming only works for predefined structured problems, while ML has the ability to adopt complex, changing, or uncertain problems. Traditional programming examples could be text calculation, sorting numbers, form validation, which are very basic or predefined. But in ML, you can use data for any problem such as spam detection, image classification, or object detection, video detection, or action recognition within video, or any type of problem. Traditional programming depends on human-defined logic, while data-driven programming depends on data quality and quantity that you are using for training the model. Traditional programming needs manual code updates for better performance, while ML model has the ability to improve automatically as you provide more data for training. Now let's understand machine learning applications. So the first application is very common and very useful, that is a recommendation system. Now recommendation system is a type of machine learning that is used to suggest you best items based on your choice and interactions. Also, social media platforms or even e-commerce platform use machine learning recommendation systems so that they can engage their customers. For example, Netflix recommendation system suggests you best movies and shows that you are most likely to enjoy. They will collect your data as an input or interaction, and based on your interaction with the movies or the items in which you are likely to enjoy, they will suggest that movies or items accordingly. So the first application could be recommendation system, which is very common and very useful in machine learning. Second example is self-driving car. You might have heard Tesla cars. Here self-driving car use machine learning and deep learning models with cameras and sensors that collect data from road or their environment, and based on that input data they navigate safely without human driving. Third example is smart assistants. Here they use machine learning NLP part, where NLP algorithm has the ability to understand, interpret and make decision for human natural languages, like such as textual or voice based data. For example, Alexa, Siri and Google Assistant can understand human languages either through text or voice, and they can respond to your voice or text accordingly. Third example is medical field, where ML model analyzes scans and patient data to detect disease early. For example, MRI detection system. Fourth example could be content moderation. You might have used any social media platform such as Facebook, Insta, any type of platform. If you upload a post or do some comments that are harmful post, or you can say that is against to their standard policy, they will automatically remove that post because they use machine learning algorithms to detect harmful posts either in text or images or even voice. Now let's discuss and understand machine learning types, because if you really want to implement end-to-end project in machine learning using Python and scikit-learn, then you need to differentiate different types of ML. First type is supervised learning, second is unsupervised learning, and then reinforcement learning. You might have heard another type that is semi-supervised learning, but we will start with these three. So let's understand supervised learning. We will understand each type of ML with four concepts: data, goal, task, you can say types, and the algorithms that we are going to use for that type of machine learning type. So supervised learning need data set, but label data. Now let's understand label data. Label data is a type of data where you have input features with corresponding predefined target labels. For example, we have this data where we have these features: age, gender, salary, scores and status. Now age, gender, salary and scores are the input features that ML model will use for learning, and status is the target column or label that ML model aims to predict. So in this data we have two things: input feature plus predefined target column or target label. So if you have these two things in any type of data set, then this problem automatically becomes supervised learning. Let me repeat: label data, supervised learning needs label data. Label data is a type of data where you have input features with corresponding target column. It could be tabular data such as this one, or it could be textual data. For example, if you have a textual data where you have two columns, text plus label such as sentiment analysis, then this also a supervised learning problem because we have two columns. One is input features, one is target column, and the goal is to predict the labels. In target column you have to predict either the labels or continuous value. Now supervised learning has further two types, classification and regression. Now here, if you want to understand which one is classification and which one is regression based on the data that you are dealing with, you have to only focus on your target column. If in your target column, you are going to predict categories, classes, groups, or labels such as happy, not happy, 0, 1, yes, no, ham, spam. Then it is called classification problem, because based on this input feature, you are going to predict categories, labels. Then if your target column has labels, categories, you are dealing with classification problem. But let's say in the same data we are going to predict scores. Now here score is the target column instead of status. So here in score we have continuous value. So if you are going to predict continuous values, then you are dealing with the regression problem, because in the regression your main goal is to predict continuous values such as prices, scores, weight, temperature. So all the continuous value, if you are dealing with continuous value in your target column, then this problem automatically becomes regression. Now for supervised learning, we have different types of algorithms such as linear regression that is used for regression problem. We have logistic regression that is used for classification problem. We have decision tree that is used for both. We have random forest used for both. Support vector machine used for both, and k-nearest neighbors. And we have a lot of model, and the good part is that scikit-learn provides all these models in 2 lines of code. Now the second type is unsupervised learning. So first step is data. Here instead of labeled data, we use unlabeled data. Now unlabeled data is a type of data where you have only input features without target column or predefined labels. Let me repeat. In unsupervised learning, we use unlabeled data. Unlabeled data is a type of data where you have only input features without predefined labels or target column. You have to create the target column during training. So here the goal is to create labels, groups, or clusters. Because the model that you are using for unsupervised learning for this data, that model will create labels by calculating similarity or distances between these records, and based on that similarity or distances, unsupervised learning model will create this target column by creating labels, or you can say groups, or you can also call them clusters. Unsupervised learning type has further 2 types, clustering and dimensionality reduction. In clustering, what we basically do, we create a target column where we have some clusters or some labels based on similarity or distance that we will discuss and explain a bit later. In dimensionality reduction, if we have a lot of data set with a lot of dimension, currently we have only 1, 2, 3, 4 dimensions. So let's say in real world use case you have 1000 dimension data. So you have to remove irrelevant or extra dimension. Then there you can use a dimensionality reduction algorithm in unsupervised learning. Algorithm that we use for unsupervised learning can be K-means clustering, that is used for clustering, hierarchical clustering, DB scan, principal component analysis that is used for dimensionality reduction, T distributor stochastic neighbor embedding that is also used for dimensionality reduction. And the third type is reinforcement learning. Now this is quite interesting and very useful type of AI or ML. Now in reinforcement learning, we basically we have an agent. We put that agent into an environment so that the agent could interact with the environment, and based on that agent activities, we can give 2 things, either penalty or either reward. For example, I have this environment and I am the developer. I have created this agent and now I have put this agent within this environment, and I have also defined for this agent that you have to perform some actions. If the agent is performing good action, then I will give rewards. If the agent is doing something wrong or something bad, then I will give some penalties so that my agent improve. This is the entire concept of reinforcement learning, where we have agent will interact in environment such as performing some actions. If the action is good and based on our output, then we will give rewards. But if the agent is doing something wrong or not based on our output, then we will give some policies such as penalties. Reinforcement learning has a lot of examples. Any device that can do automatic thing is reinforcement learning. For example, game playing, for example, AlphaGo, all the robotics, either humanoid robot or industry-based robots, self-driving cars, or even drone cameras. Now, the very important and my favorite concept for beginner in machine learning is dataset, types of dataset, and features. So once you becomes a machine learning engineer and works on real world problem, and the first step is to collect a data set, which is totally depends on your problem statement. So if you are working on classification on the regression problem, then the first type is tabular data, where you have input features with corresponding target values or target columns. So the first type is tabular data if you are working on supervised learning problems such as classification and regression. But if you are working with textual data such as text, like detecting emotion within text, text generation, text classification, then this data becomes textual data, which is a part of NLP in machine learning. The third type of data set in machine learning is images data, where we have two types of data. If you are going to classify an image, then it's become classification problem. But if you are going to detect an object within an image, then it becomes a regression problem. So in images we have two types of data: image classification or object detection within image. And the fourth type of data set is audio data. For example, if you are going to detect a voice or sound within the audio, then it becomes a classification problem. And if you are going to transcript like generate a text from audio or even convert text back into audio, then it's become some time of generation problem. So this is again a part of NLP problem. And the last type of data set in machine learning is video data. For example, video classification, action recognition within a video, or even object detection within video. So once you build a model in machine learning, you will work mostly in these 5 types of data set. Now let's understand features and target. This is quite simple. So for example, let's say we have this data set, tabular data, where we have some input features like person, name, age, and income, and we have this marital status. So based on person name, age, income, we are going to predict either the person is single or married. So this is a classification problem. But what is feature or what is target? So feature are the variables, columns, or the values that we used or the model used to make prediction, while labels, target, classes, continuous value are the output values that the model aims to predict. So what is the concept basically? Here the model try to learn the mapping between input features and target column. Now if you want to master the mathematics behind machine learning, there instead of features and target you will see X and Y like this. So X belongs to feature, Y belongs to target or labels. Now in machine learning, once you collect the data set, either tabular data, textual data, audio data, images data, depends on your problem statement, then you have to do train test split, so that some data is used for training purposes and some data is used for testing purposes. This is known as train test split in machine learning. So basically we have training data that is used for fitting the model and testing data that is used to check the model for performance, that how the model is good for real world use cases. So this will be your actual data. What we basically do, we take 80% data and we create another set by the name of training set. We use this 80% data for training the model, and remaining 20% data will be our validation or testing data that we will use for testing purposes so that we can check our model performance. Now, once you collect data, then you do train test split, then you have to select a machine learning model so that you can train that model and you can use for real world use cases. Now, the model is basically depends on your problem statement. If you are dealing with classification problem, then your model becomes classifier. If you are dealing with regression problem, such as you are going to predict continuous value, then your model becomes a regressor. Now, once you train a model, then you need to evaluate that model so that you can check your model performance, that how good your AI or AI model is. Now, this is very interesting and very important part in machine learning, which is called evaluation, where basically you measure performance using different types of matrices, but you need to understand these matrices. So here we have different matrices such as confusion matrix, we have classification report matrices, and we have some regression matrices such as mean squared error, root mean squared error, mean absolute error, R squared. Or we have some other matrices such as Silothe score, Davis, Baldwin index, Dunn index, inertia, sorry for that, or adjusted rand index. Let's differentiate that what all these matrices and when to use when matrices or which matrices. Sorry. So if you have trained a classification model, classifier, then you can only use confusion matrix and classification report for evaluating your classifier. But if you have trained a regression model, a regressor, then you are not able to use confusion matrix or classification report. You have to use regression matrices. But if you have used unsupervised learning algorithms such as clustering, K-mean clustering, then you are not able to use these matrices. You can only use these matrices: Silothe score, Davis, Baldwin index, Dunn index, inertia, that we will discuss. Now let's understand one by one that what are all these matrices. So first, confusion matrix. Confusion matrix basically tells you about your trained model two things. So confusion matrix basically compare actual classes versus predicted classes and telling you two things about your model, that how your model is good after training. So basically it tells two things by comparing actual classes versus predicted classes. The first is correct classification by comparing actual versus predicted. The second is misclassification by comparing again actual versus predicted. So if you ask me that what is confusion matrix and what it tells about the trained model, then I would say that it just tells about your model two things, that how your model is correctly classifying the predicted classes or wrongly classification. So correct classification and misclassification. If you get values diagonally, then these are the correct classification. And if you are getting values like this, then these are the misclassification for these actual versus predicted classes. You will better understand when we will implement this thing in scikit-learn. Now let's talk about classification report. So classification report tells you one thing, your model confidence for each class. So let's say we have two classes, one is 0, one is 1. So for each class it tells four things: precision, recall, F1 score and support. So for 0 class, the model is telling us 0.77 precision, 86 recall, 81 F1 score, and this is the support. And for 1 class, the model confidence is 84, 75, 79, and this much. So here, if you are getting higher values, either for 0 class or for 1 class, it could be precision, recall, F1 score. But after all, if you are getting higher value, then it means that your model has a higher confidence, and this is a good sign. If you are getting lower values such as 50, 55, 60, 65, then it means that your model has low confidence for that particular class. And the good part is that classification report is also telling you overall accuracy of your model. And the good part is that in scikit-learn you can use one line of code for evaluating your classifier, either confusion matrix or classification report. But what if instead of classifier we have trained a regressor? Then as I mentioned that you will not be able to use confusion matrix or classification report, but instead what you can do, you can use mean squared error for calculating error by using this formula. Let me write here: actual continuous value minus predicted continuous value, like this. So this is the formula for calculating the error of your regressor. This formula belongs to mean absolute error, but you can also use mean squared error, and the formula just becomes like this. If you use root mean squared error, then the formula becomes like this. So this three formula you can use any one, it will just tell you your model error. But if you want the accuracy of your regressor, such as we have checked for our classifier, then you cannot use classification report or confusion matrix. Instead you use R squared error that tells your regressor accuracy. But what if you have trained unsupervised learning algorithms such as k-mean clustering, DB scan? Then you can use selector score, Davis Bolden index. If it is lower, that is good, and Dunn index, if it is higher, such as 80, 85, 90, then it is good. And inertia, there is a concept in unsupervised learning, you have to select k number of cluster that we will discuss a bit later. You can check that with the help of inertia, which is also known as SSC. And adjusted rand index, or we have another matrices, normalized mutual information, which is also known as NMI. So let's now understand the final part of your workflow, that is deployment or prediction system. So you have collected the data, you have done pre-processing, trend split, then you have trained your machine learning model, then you have evaluated that model accordingly. Now you have to use that model, you have to bring into the real world so that people can access it. So what you will do, you will simply create a user interface or some kind of website or desktop type of UI or app where user will input their data in real time. That data will go to your trend model behind the scene, or you have used some backend. You will get that data through the user interface. That data will be passed to your trend model, and that model will predict. If it is a classifier, it will predict either yes or no. If it is a regressor, then it will predict some kind of continuous value. If it is a unsupervised learning, then again it will predict some kind of cluster, either 1, 2 or 3, depends on your problem. So but here deployment means that you have to bring this your trend model into a real world so that people can take advantage of this model. Now let's understand supervised learning algorithms and what is the difference between regression and classification, because this is very important. So again, let me repeat, for supervised learning we use label data. Label data is a type of data where you have input plus or target column, input which is represented by X and target which is represented by Y. This is called supervised learning. But again, here we have two types, either classification or regressor, which totally depends on your Y. If in Y you are going to predict classes or labels, then it becomes classification problem. If you are going to predict continuous values, then your Y becomes a regression problem. So we have different types of models such as linear regression, logistic, decision tree, random forest, SVM. But what is the difference? So let's say we have this data where we have only two columns. One is feature, which is X, one is Y. And let's say this is a regression problem. And total we have different rows or records. So once you plot this data, it looks like this. This is our X, this is our Y. And the data after plotting looks like this. So if you train a regression model on this data, what the regression model will do, it will try to draw a best fit line like this, so that this model has lower error and higher R square score. This is called regression problem. So here regression is basically, a regression model is trying to map between this X and Y, and to reduce the error it will draw a best fit line. For example, it could be, let's say this is my plotted data like this. These are the data points. The plot could be like this, the plot could be like this, the plot could be like this, the plot could be like this. Now if you ask me which one is the best fit line, then I would say this one, because this line has lower error in comparison to other plots. But what if the same problem is, instead of regression, here we have 0, 1 for the target column. Let's say classification problem. And after plotted the data, it looks like this. Some data points are plotted right here. Some data points are plotted right here. Again, we have X and Y. And if you train a regression model instead of classifier, that regression model will try to draw a best fit line like this. But here we are losing a lot of data points. We have a lot of errors. So this is not a good practice. So let me draw the same thing right here. This is X and this is Y. And some data points are here and some data points are here. So here, if you draw a regressor and a regressor model, then this model will not be able to, just let me take a pen. This model will not be able to get better representation. So instead, what we do, we use a classifier. And let's say we have used logistic regression. And logistic regression basically take this curve, or you can say this shape. Here logistic regression tried to catch all data points, but here we have some boundary with some threshold value 0.5. I'm not going in detail, I'm just differentiating between regression problems and classification problems, or how the model works. So if we are getting data points like this or like this above this line, we will assign all these data points to one class, or let's say 0 class. But if we are getting data points like this or this one before this boundary line or below this boundary line, we will assign to 0 class. So here we resolve the same problem, but instead of using a regression, we use logistic regression or classifier. Unsupervised learning has different algorithm like k-means, dbScan, agglomerative, but as we already discussed that they use unlabeled data where you have some input features. Let's say x1, x3. These are the input features, and we don't have any target. We have to create that target. So this is unlabeled data. So if you plot all these unlabeled data, so let's say we have this data after plotting. Now here unsupervised learning or clustering algorithm, let's say k-mean clustering, what it will do, randomly, the first step is unsupervised learning is to select the number of cluster. So let's say we have selected 3. So the first step is to take 3 data points as a centroid. This data point will be my centroid, and this data point will be my centroid, and this data point will be my centroid. Because my k number is 3 and my number of cluster is 3. Finally, I am going to create in target column, I am going to create 3 classes or 3 cluster or 3 labels. Let's say 0, 1 and 2. So total 3. So my number is 3. Now this depends on your inertia that we have discussed previously, and you will see in code. So here, first step is to select the number of cluster, which is 3. You can do beforehand or manually, or you can use some matrices that which number is good, either 4, 5. Let's say 3. So now we have 3 centroid. So in unsupervised learning, k-means clustering, the main concept is calculating similarity or distance for each data point from your centroid. So we will calculate this distance, this data point distance from this centroid, this data point, this data point, this data point, this, also this. So what we have done here, this is the center point, and for this point we are calculating all the data points. Now as a human being, you can easily differentiate and you can easily make decision that all these data points are nearest to this centroid. So this we will assign all these nearest data points to this centroid, and this will become our first cluster. Now from this centroid we will calculate all data points, distance or similarity, like this, all data points. But again, as a human being, you can easily make decision that all these data points are nearest to this centroid. So we will assign to this all these data point to this centroid, and we will call it cluster 1. And finally, this will work in the same way. So now all these data point belong to this cluster, which is 0. All data point belong to this cluster, which is 1. All these data point belong to this cluster, which is 2. So now we have created successfully a target column, or you can say clustering, labels or groups. This is called unsupervised learning. Now again, clustering, dbScan, agglomerative has the working flow could be different, but at the end they will create clusters. Now let's understand machine learning project workflow using Python. So the first step, you have to collect a data set which depends on your problem statement. Once you get data, you can get from your client, you can get from online sources such as Kaggle or UCI. But once you get the data, you have to clean this data using Jupyter Notebook, Google Colab, or VS Code. Okay, here you have to clean, you have to prepare, you have to manipulate your data set, you have to do trend test split in step 2. In step 3, you have to select your model. If your problem is regression, then you will select a regressor. If your problem is classification, you will select classifier, and accordingly unsupervised learning algorithm depends on your data. So once you train a model, then you will test that model using different matrices that we have already discussed. Once you confirm with your model, in 5 steps you have to improve your model. Once you improve model, then you will have final step, which is 6 step. Have to deploy your model so that people can use it. Now let's use Python, VS Code, scikit-learn to implement an end-to-end machine learning project. So you will get the data set and this Jupyter Notebook code in this video description. You can use Google Colab, you can use Jupyter Notebook, Anaconda environment, or even you can use VS Code. But let me explain. So the first step is dataset loading. So here you have to import OS, NumPy, and Panda, and since we have diabetes.csv, then you have to use read CSV function. So this is the data where we have these input features, and this is the target or you can say label where we have 0 and 1. So it means this is a supervised classification problem because we have input features with corresponding target column, but in target column we have classes, categories, so it is a classification problem. The second step is data pre-processing, or you can say exploratory data analysis, where you can check missing values, or you can also get the information of your data by using df.info. You can also check your df statistic. You can do anything with it. So finally you can say these are the information of our data set. I'll just share this notebook, further you can explore, and these are the statistics for all the numerical columns where you'll get count, mean, standard deviation, mean, all the 3 percentiles, and max and mean values. And these are the visualization where you can see for 0 and 1 classes we have these frequencies, and these are the distribution of our all numerical data. You will better understand once you explore this notebook. And these are the heat map. And then we have trend test split, where basically we have X where all the input features, and then we have Y with only the target column. Then we have used scikit-learn trend test split. So from scikit-learn.model selection you have to import trend test split, where you have to pass your X and Y with test size 0.2. It's mean that 80% data will be stored in X trend and Y trend, and remaining 20% data will be stored in X test and Y test. Then we have some classifier model, just such as logistic regression. So from sklearn.linear model logistic regression, and we also need to evaluate this model. Then you have to import from sklearn.matrices classification report and confusion matrix. These things are quite basic. Then you have to create an object of your model. This is a logistic regression. Then we have trained the model by using model.fit by passing our X trend and Y trend, which is the 80% data. And then we have tested our model by passing 20% data. Now these are the model prediction, but we have already actual data, which is Y test. Now we have to compare this Y test with this Y pred. So here we have used classification report by passing actual data, which is Y versus predicted data, which is Y pred, and we have also done for confusion matrix. And this code is just for saving the model, so later we can deploy it or we can integrate it with the app. So this is the classification report for model. For 0 and 1 you can see precision, recall, F1 score, which are quite good. So this is the classification report for both classes 0 and 1. We have precision, recall, F1 score, and this is the confusion matrix. These are the correct classification, and these are the misclassification. Then we have trained in the same way random forest, where you have to import from ensemble random forest classifier. The rest things are same, as you can see. And for random forest we have this classification report, and these are the confusion matrix. Then we have deployed this model. Now here I have just shown for tutorial purposes directly in the notebook, but you can use the same model and you can create a user interface and you can integrate. Here randomly I have taken this record, and so this is the record on 10th row I have taken, and then I have passed this record to my model. Now at a time either the model will predict either 0 or 1. Then I have checked. If it is 1, then print diabetes, otherwise no diabetes. So the model has predicted 1, and here the condition becomes 1. 0, the model has predicted 0, the condition becomes 0. So here you can see no diabetes. So in this way you can implement an end-to-end machine learning workflow. Now you will get this code and the data set, and you can further explore this code. Thank you so much.